So in question 38, we're asking the gravitational force between two electrons. So once again, we're talking about the gravitational force between two objects. They're talking about electrons, so the masses are very, very small. So we probably are going to be talking about a very, very small force, even though it's relatively close, a meter apart. We're talking about a very, very, very small force. So what this problem is asking is, what is the mass of an electron? So we're still using the same formula, force equals gravitational constant, mass 1, mass 2 over r squared, but we want to solve for mass. But what we need to also assume is that every electron is the same mass. So when we look at mass 1 and mass 2, what we're really looking at is this formula, gravitational constant of mass squared divided by r squared. And this mass squared right here is because 2 electrons of same mass. So once we understand that they're the same mass and we have that solved, now we want to manipulate the formula to solve for mass by itself. So doing that, let's multiply both sides by r squared, divide both sides by g, and then just remember that since this is squared, we want to square root everything on both sides. So let's just clean this up a little bit to make it look good. Force r squared over g is going to equal our mass of an electron. So now let's look at our data. Well, the r is 1 meter. Our force is 5.42 times 10 to the negative 71 newtons. Our g is always given 6.67 times 10 to the negative 11 Newton meters squared, kilograms squared. I apologize. No, it is Newton squared, meters squared, kilograms squared. So now when we plug in, we look at the force, square root. The force we said was 5.42 times 10 to the negative 71 newtons. That takes care of the F. The r squared, that's 1 meter squared, all over g, which is 6.67 times 10 to the negative 11th Newton meters squared, kilogram squared. So when we're looking at this, just to simplify it down, we know that the newtons will cancel out each other. This meter, once it's squared, will cancel out here. This kilogram squared is underneath the radical, and because it's on the bottom of a fraction on the bottom of another fraction, it will come up top, and our answer will be in kilograms. That's what we're looking for. And once again, the hardest part of this problem is probably putting it into your calculator, and as you put it into your calculator, it should ultimately give you the answer of 8.13 times 10 to the negative 61 kilograms. I apologize, that's the squared unit, and then we want to take the square root of that, which comes out to 9.01 times 10 to the negative 31 kilograms, which is the mass of an electron. And just notice that it is very small, which is what should be expected.